Yeah. So in this question too, we need to find the Taylor series and Lorentz series expansions. Okay, like all possible cases. Taylor series and Lorentz series are basically the same when both the regions intersect. Well, I'll just show you here. But firstly, let's find the point set with the function not analytic. If we factor the denominator, z square minus 2z minus 3, we can write it as minus 3z plus 1z minus 3. Take z common, z minus 3 plus z minus 3. So we get z plus 1 and z minus 3. So we can write it as z plus 1 and z minus 3. Nice. So the points at which a function not analytic are z is equal to minus 1 and z is equal to 3. So 3 cases, okay. Ignore the sign because we are taking mod. That's the only reason. So case 1 would be mod of z is less than 1. Case 2 would be mod of z is greater than 1, less than 3, like a sandwich of sorts. And third case would be mod of z is greater than 3. Case 1, case 2, case 3. Now, when our mod of z is less than 1, it is also less than 3, no? Basically, if you see the region, this is mod of z is equal to 1. If less than 1, then it always lie in the circle. It won't lie even on the boundary of the circle. That's what less than 1 means. Because on the boundary of the circle, value of z would be 1. Okay? Or mod of z would be 1. So everything inside this region would be case 1. Then for case, what do you say? For case 2, we'd have this circle here from 3 to minus 3. So in case 2 is basically this entire region, like donut region. And for case 3 is basically everything outside this region. Exclude this, but everything outside. 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 Yes, sir. So now, if you see the intersection of these two regions, like this one and z is equal to 3 wala 1, is this, no? Z is equal to 1, less than 1, sorry, less than 1. Yeah. So this is the intersection. So in this region, our Taylor series and Lorentz series would be the same. That is, when mod of z is less than 1, as well as mod of z is less than 3. So case 1 is mod of z less than 1. This is basically the one for Taylor and Lorentz. Oh yeah, I forgot. Before solving the cases, we could just simplify this using partial fractions. So f of z is z minus 1 upon z plus 1 into z minus 3, which could be written as a upon z plus 1 plus b upon z minus 3. Then now we could cross multiply, so we get z minus 1 is equal to a into z minus 3 plus b into z plus 1. Now if you put z ka value as minus 1, you get minus 2 over here and you'll get minus 4. So you get minus 2 is equal to minus 4 and this will become 0. So a is basically 1 by 2. Now if you put z ka value as 3, you'll get 4 over here, this will be 0, and this is 3 minus 2, which is again 2. So you would get 2 is equal to 4 times b, which is b is equal to 1 by 2. Okay. So now we got a and b ka value, so we can write a function as, since both have 1 by 2, I'm just taking that common. Okay. So this is 1 by 2, 1 upon z plus 1 plus b, b is also 1 by 2, which we took common, so 1 upon z minus 3. Okay, z plus 1 and z minus 3 done. Now we can move on to the cases. In case 1, we are basically finding both the Taylor and Lorentz series. They are one and the same in this case. Case 1, when all the conditions are satisfied. Conditions as in z is less than 1 also, and mod of z is less than 3 also. वैसे if less than 1 is obviously less than 3 also, no? वैसे. So now we write this as 1 plus minus something, 1 plus minus something. Over here we'll have to take minus 3 common out. Over here we could just rearrange it. So we get half 1 upon 1 plus something, so 1 plus z, plus if we take minus 3 common here, minus 3 comes out here, and we write this as 1 minus z by 3. Nice. Now if mod of z is less than 1, then mod of 3 is obviously less than 1, no? Mod of z by 3 is obviously less than 1, as follows. If you just divide both sides by 3, mod of z by 3 is less than 1 by 3. If it's less than 1 by 3 is obviously less than 1 also. So therefore our condition for this thing to be less than 1 and this thing to be less than 1 is satisfied. So now we can use our standard expansions. So the expansion for 1 upon 1 plus x is 1 minus z plus z square minus z cube dot dot dot. And for this one we can take minus 1 by 3 out common, and we'll get 1 plus z by 3 plus z square by 3 square plus dot dot dot. So this is the answer to our case 1. Now for case 2, our mod of z lies between 1 and 3. Okay. So firstly just rewrite f of z just for convenience, which is half 1 upon, what is it? 1 upon, where did the function go? 1 upon 1 plus z upon 1 upon z minus 3. 1 upon 1 plus z plus 1 upon z minus 3. Okay. So now here we have two conditions. One is less than mod of z, and other is mod of z is less than 3. We always need to write it in the form of something less than 1. Okay. So in this case we can do that by just shifting it here. So you get less than 1 in this way. And then for this case we could less than 1, no? So yeah, just divide by 3. If you divide by 3, we get mod of z by 3 is less than 1. So now over here we need to get z by 3 somehow, and over here we need to get 1 by z somehow. That's kind of the logic. So in order to get 1 by z here, we need to take z common now. If we take z common, we get 1 plus 1 by z. I rearranged it, but yeah. Plus over here we need to take minus, wait one second. Yeah, minus 3 will be taken common. So plus minus 1 by 3, and we'll get 1 minus z by 3. It should be correct, I guess. Yeah, okay. So now 1 by z is less than 1, and z by 3 is also less than 1. So our conditions are satisfied, so we can use our standard expansions. So we get 1 by z. This is as it is, okay, 1 by z. This is 2 here, this is z. And we get 1, this is 1 upon 1 plus x as a format. So 1 plus minus, alternating sign. Plus 1 minus 1 by z plus 1 by z square minus dot dot dot. And now we have minus 1 by 3, the constant here. Then we'll have, this is 1 upon 1 minus x wala form. So we'll have all positive term. 1 plus z by 3 plus z square by 3 square plus dot dot dot. You could solve it further if you'd like, but I like to keep it as it is. This is a Lorentz series expansion for case 2. where mod of z is greater than 1 but less than 3. And finally, let's go on to case 3. So in this case, our mod of z is basically greater than 3. So for this case, if you see, we need to write it in the form of something less than 1, no? Or in this case, since it's the other way around, we could write it as, what do you say, 1 greater than something. Basically, there should be 1 on one end, and the sign should be opening towards it. So now, f of z, no. First, we don't need to rewrite that, it's right here. F of z is 1 by 2 into this 1 upon 1 plus z plus 1 upon z minus 3, okay? So now, we have this condition here, and we need to first write it in the form of this or this. Since we have a greater than wala sign, 1 is greater than something, we need to write it as 1 is greater than something. We can divide both sides by mod of z, so we get 1 is greater than 3 by mod of z. Meeps. So yeah, we got that. Now let's try to get this, and also simultaneously we could also write, or rather not simultaneous, similarly we can also write 1 upon mod of z should be less than 1, because if you multiply it by 3 and it's still less than 1, then if you divide it by 3 it should be smaller than that. No, kind of like if you want to derive it actually, then you'll get it as this, okay? So you divide this by 3, okay, both sides, so you get this 1 upon z is less than 1 by 3, and obviously 1 by 3 is less than 1, therefore we can write 1 is greater than this thing, 1 by mod of z. Okay, so now our function, okay, so we need 1 by z wala term and we need 3 by z. So in order to get 1 by z in this function, we could take z common out here, and over here we need to get 3 by z. So we'll be taking wait one second, we'll be needing 3 by z, yeah. So we need to take a z common out here. Okay, so if we take z common out, we'll get 1 by z into 1 plus 1 by z, plus we'll be taking z common out, no, this time from here. So if we take z common out, we get 1 minus 3 by z, and there'll be a z outside. So 1 by z into 1 minus 3 by z. Okay, and we can take the 1 by z also common out. So we get 1 by 2z, and also since we know that this thing 3 by mod of z is less than 1 and 1 by mod of z is less than 1. See, this part and this part both should be less than 1, only then we could use our standard expansion. So now we could write, we could just expand it. So this is the form 1 upon 1 plus x. So alternating plus sign, minus sign, plus sign, minus sign, and increasing powers. So minus 1 by z plus 1 by z square minus dot dot dot. Then we have another one, which is, we took this 1 by z common out, okay, it's here. Over here we'll have 1, and since this is 1 upon 1 minus x wala form, so we'll have all positive terms. 1 plus 3 by z plus 3 square by z square plus dot dot dot. So this is a this is a Lorentz series expansion. Even this one which we calculated was a Lorentz series expansion, and the first one which we calculated, this is a Lorentz series expansion and Taylor series expansion. Both converge at this point because it's analytic for z less than 1 and as well as z less than 3, basically this center wala region. वैसे